In this question, seven identical cylinders are being held tightly together, each of radius 20 centimeter, with centers of the cylinders are A, B, C, D, E, and F. We have to show that the radius of each cylinder is given there 20 centimeter, and we have to show that the angle PAQ is pi by 3 radians. Then the length of the rope, area of the hexagon, and the total area enclosed by rope is being to be calculated in this figure there. Since we know that there are six sectors of arc PQ like this here, and six. So we know that they are forming a circle there. So six times of this angle PAQ should be equal to 2 pi, because total angle about the points in a circle is 2 pi. So here angle PAQ should be equal to 2 pi by 6, or that is equal to pi by 3 radian, which is in the first part. We have to show it there. Then in the second part, they are asking about show the length of that rope. So because it was a thin rope which is tightly held together, so it is arc PQ, then P to this, then this arc, then this, and this whole is being wrapped in that thin rope there. So we have to calculate the length of that rope there. We know that the circles are touching each other. So this length is 20 and this length is also 20. So the total length of this rope is 40. So it is 40 here, 40 here, 40 here. So it means it should be equal to the length of rope is 6 times for this 40 plus at every corner it is being wrapped about those cylinders. So it is the arc PQ, and which is also multiplied by 6 there. So we know that it is 6 into 240, that is 240 plus 6, arc length is r there, radius is 20, and the theta there is pi by 3. So 3 2s are 6. So it should be equal to 240 plus 40 root 3 centimeter is the total length of that rope which is being used for this part there. In the third part, find the area of the regular hexagon. If you look at those figures, this is A, this is B, this is C, this is D, this is E, and this one is F. They are all joined together with their centers. And we have to find out the area of this regular hexagon. If we join A with D, B with E, and F with C, then they are going to meet each other at this point. Let's say that is O there. Since each of this length is 40, because the circles are touching each other, so this is 20, so this is 20, so that should be equal to 40 here. And the angle there, because it's a regular hexagon, it is pi by 3. So the area of this regular hexagon is 6 times the area of the triangle. Triangle AOF. So it should be equal to 6. Area of triangle is half into 40 into 40 into sine of 60, or sine of pi by 3. So it should be equal to 3 times of 40 into 40 into sine of pi by 3 is root 3 over 2. So 2400 root 3 centimeter square. is the area of the regular hexagon in this part there. Then they are asking find the total area of that rope enclosed for the cylinders there. So the fourth part is the total area of that. It is first we have calculated this interior which is on hexagon, and that area is equal to 2400 root 3 plus this is the rope length there which is being calculated as 6 times of that. So it should be equal to plus 6 times the area of rectangle which is having the length 40 into 20 plus 6 times of the area of the sector which is equal to half into 20 square into sine of half r square theta, and theta is equal to pi by 3. So that should be equal to 2400 root 3 plus 806 800 centimeter square plus 2 3s are 6 and cancel out. So it should be equal to 400 root pi. So this is the total area enclosed within the rope which is going to enclose these cylinders inside of that figure there. So this is a complete solution of this question there.